Hello, Jeremy here. In this video, we will go over Boolean expressions in the REPL. Then we'll go into presenter.py and fix up the program. So let's begin. Okay, I'm going to go ahead and open up the REPL. So a Boolean expression is an expression that's Boolean. What an expression is, it's something in Python that returns a value that we can evaluate. We've been doing expressions quite a lot. The expression is something like 2 plus 2. That's 4. It's 2 plus 2 is the expression whose value is 4. You can see that typically an expression can be replaced and substituted without necessarily changing what's going on. Okay, now a Boolean expression is like this, but it returns true or false. So it's anything that evaluates a true or false. Equality is a good way to do it. 4 equals 4, that's true. 4 equals 2, that's false. This is a Boolean expression. 2 is less than 4. This is a Boolean expression, greater than 4. These are all Boolean expressions. So because it returns a value, we can assign it, which is interesting. Because we've been used to going if some sort of expression. If 2 is less than 4, then we do something. A equals 1, else equals 2. And we look at A and we go, hey, it's 1 because 2 is less than 4. So that is how we're used to doing it. We're saying if whatever this expression evaluates to, if that's true, we do this, else we do this. However, this is being evaluated. This is being evaluated and it becomes true, so if true. But we still can store that in a variable. So x has a variable and x is false. This is interesting because we can do expression. We can say x equals, I don't know, let's do some y equals 2, z equals 4. And we can say that truth equals y is less than 5 and z is less than 10. We can do something like that. And truth is true. Okay, so that's a Boolean expression. Oh, and an or. I've been using these and I haven't really shown what this and means and what the or means that we've been using. And is a logical and, or is a logical or, compared to a bitwise and a bitwise or. I'll do all 4 of them to show the difference. A logical and an or, like when we did the binary and logical operations video, which is episode 10, and means all is true. However, in Python, we can chain this. We can go true and true and true. And we can do as many as we want. That's true. True and false and true. That's false. So logical ands and ors work off of Python's Boolean true and false, which are special objects. AD true, AD false. So They are specific objects in memory that represent the values true and false. And you can tell that true points to the same value, true and false. So it's evaluating to the same object. All right. Or works as expected. So if it's false or true, you'll get true. If it's false or false, you'll get false. So if any of them are true, you'll get true. So in Python, I believe you can do leading 0 and do binary. So if we go 0, 1, 0, 1, that should be 5. And do I have to do B? Yeah, okay. So 0B, 1, 0, 1 is binary. So to show you that you can do 0B, 1, 1, 1, 1, and 0B, 1, 1, 0, 0, 1. I want to print it in binary, but we can see that it's 9. So can I do bin like this? Yay! That's exactly what I wanted. Cool. So you can see that the zeros when they ANDed these ones, they become zeros in the result here. So this is exactly what you would expect from the previous lesson. And if you ORed these together, you'd get a bunch of ones. Great. So that is what you would expect from the previous lesson if you did the bit by bit for each number representation. And you can tell Python is being convenient in telling you the decimal representation of this binary number. You can also do a hexadecimal representation. And represent this in hex. All right, so good. Okay, so back to Boolean expressions. We can use these Boolean expressions to fix up the code in some interesting different ways. So I'm going to go ahead and show you that we can actually replace if statements that are setting Boolean values, which is a little bit unusual, a little bit interesting, and it may be more confusing than the if statement itself. So you're going to have to make a judgment. However, it could be better, and it's something you have to play with. So we're going to do it, and I'm going to actually see if it's better to keep it this way or not. All right, so it's actually down here that we're going to do it. We have this running is false. And we're going to try to create this into a Boolean expression. So we don't need all these if statements. And we'll see if this reads better when we change it or not. However, the first update I can do doesn't even require a Boolean. It requires us to combine these two statements, which we can do by using the member, by creating by changing it like this. So we go, if the event key is in this tuple, so we're creating a collection, we're going to say this guy, and cut you out of there. Alright, cool. Alright, so when we read this, it says if this key that we typed in the main event loop, this is processing the keyboard events here. So we get a key up event, and it is, the key we press is in this set, which is the escape key and the Q key. So if this key is either the escape key or the Q key, this will be true. And then we set running equal to false. Also, here, we want to go say running equals, we only want to set it to false. So we want to go not whatever is here. So if, right, okay, so let's take this guy out here just so you can see. If the event is quit, if we have a quit event, and the event type is a quit event type, this is true. And we want this to be false. That would allow running to be false. If it's not a quit event, so this is false, then running will be true. Alright, so we just replicated that first statement. Or, we're going to do this to make it easier to read. We have a key up event. Now here's the key part, and. Okay, so when you have a embedded if statement like this, if this is true and this is true, then we do this. So if the key up event is true and this is true, so we go and grab this, then running should be false. So if this is true, we have hit the escape key or we have hit the Q key. So if we hit the escape key or the Q key, or we've got a quit event, this expression would be true. And then we not that expression, which makes it false. Otherwise, this expression is false, and we not it, and it becomes true. Which gives us this. Which is definitely unique. Is this better? Is this easier to understand? So we're running when we don't quit, or we don't have a key up event and it's not escape and it's not Q. I don't know. Maybe. How about you let me know this makes more sense than the if statement? It seems about the same to me. Okay. Is there anything else we can do for Booleans? I still want to update the position here, position there. Nothing there. Nothing here. Nothing there. Not seeing anything there. Nothing there. Yeah, that was the only thing I could find. Okay, then this is the end of the episode, and I will see you later. Have a good day, and thanks for watching. Bye.